So when we have a first order differential equation, a first order ordinary differential equation, we have two particular methods to solve this differential equation. First of all, we could use separable method to solve the ordinary differential equation, but separable is applicable for linear and nonlinear differential equations. We covered this in last lecture. They must be first order equations, and the ultimate format is f of y, a function of y, and dy equals to a function of x dx. So you ultimately want to have the x terms on the right hand side or the left, doesn't matter, with the dx attached to it, and on the left hand side you want to have the y function, the y terms attached to the dy function. So if you're able to create this form, you are able to integrate both sides and finally solve the differential equation. Well, this lecture we will be covering integrating factor, and this is another method we are able to solve only linear ordinary differential equations, and they also must be first order. So note that if we have a nonlinear differential equation, we are unable to use integrating factor. Other than that, most of the time we are able to use integrating factor, but sometimes we will choose to use separable method because it will be easier compared to integrating factor, and we will see examples on those on the following lectures. So now let's start on some examples on integrating factor. So integrating factor is a very useful method to solve first order differential equations. First of all, what we want to do is create the standard form for this differential equation. Notice that the y prime term, the coefficient is 1. We don't have any weird coefficient like 5 or anything attached to it. So make sure this y prime is being there alone itself. Okay, and then you're gonna have a p of x term attached to y, and this p of x term is very crucial when we want to solve the integrating factor problems. And at the end you're gonna have a q of x attached to here. So when I talk about a p of x or a q of x, they're just functions including x, just functions of x. So once we have this format in our differential equation, what we want to do is find the integrating factor. Integrating factor is a function of x. It is the usual notation is I of x, and the formula for that is e to the power of the integral of p of x. The p of x is right over here, so you're gonna put that p of x into this integral dx, and once you solve this integral, you will have your I of x term. And then once you have your I of x, you're going to multiply both sides of this differential equation. Both sides will be multiplied with I of x. So the left hand side, we're going to have I of x multiplied with y prime plus p xy. This is basically this part, the left hand side of the differential equation, and the right hand side will be I of x multiplied with q of x. So we will keep the balance in this equation and nothing will be changed because we're just multiplying the same thing both sides. For example, if this feels complicated, imagine you have 2 equals 2, right? And multiply both sides with 3, you will have 3 times 2 equals to 3 times 2, which means 6 equals 6. And that's true no matter what. So we are keeping the balance of the differential equation when we multiply I of x with both sides. Then something very interesting happens over here. We are having something like I hope you remember product rule. Product rule is basically when you have, let's say, y times x, okay? And you want to take the derivative of y times x. You take the derivative of the first one, and we will be doing implicit differentiation. The differentiation will be respect to x. So we will have y prime times x plus and derivative of x will be 1, so you will have y, and this will be the derivative of y times x. Well, once you do this multiplication on the left hand side, you will have a product rule derivative on the left hand side, my bad. So you will be able to write this as d dx y times I of x, because once you do this, you have to get this format. If you're not getting the derivative of this product, then you must have done something wrong with the integrating factor or the multiplication. So you will have this format on the left hand side, and we will cover this in more detail with more examples. On the right hand side, you're going to have I of x times q of x, and then in order to solve the differential equation, remember guys, solving the differential equation means you want to solve for y, you want to find what y is. So you're going to integrate both sides. When you integrate the left hand side, you're going to get rid of the d dx with the integral from the fundamental theorem of calculus. And then on the right hand side, you're going to have integral of I of x times q of x dx. Solving this integral will generate you some kind of x function. Let's call this t of x. It doesn't matter what it is. And then plus c. And then you're going to say y equals to this divided by I of x. And once you get this, you're able to solve this differential equation, because we're gonna know what y is in terms of x. So this will ultimately help us solve this differential equation. Well, we also will have in the future initial value problems. And basically what these are is they're gonna give you a y value. Let's say y of 0 equals to 0. And then once you are at this point of the differential equation, you're gonna plug this 0 as for x, and this value will be for y, and then you're going to be able to find what c is, and solving for c will generate a specific differential equation, a particular differential equation, the solution for this differential equation, which will be very useful in modeling with differential equations. So I'd like to move on some examples now. Okay, here is a very, very, very powerful example. I hope you guys can solve this. So let's start with what we can do about this differential equation. First of all, I'd like to ask each and every one of you, is this differential equation in standard form? The answer is no. This differential equation is not in standard form, because this 7x squared is attached to y prime. So what you want to do in the first step is to make this differential in standard form. So how can we make this differential equation look like a standard form? Well, since we have this attached to y prime, what if we divide everything with 7x squared? And we would be able to leave y prime ultimately alone itself. So that would work. So we can divide everything by 7x squared. So let's divide everything by 7x squared. Well, since we're dividing every part of this with 7x squared, we would not change anything in this differential equation, which is why we can do that. So we're going to have y prime plus 1 over x times y equals to 2x. Awesome. Now, since we have gathered our differential equation in standard form, we are able to classify this x term as p of x. Let's call this p of x, and this could be called q of x. Well, now that we have our p of x, we must find our integrating factor. So integrating factor is the e to the integral of p of x dx. Well, the integral of p of x dx, is the integral of 1 over x dx. Well, you must know this at this point. The integral of 1 over x dx will be ln of x. You might ask, why do we not have this plus c over here? Well, you normally would have that plus c, but since you're using the integrating factor, we don't include it. Since also we're gonna include a plus c at the end of the next next integration. So you don't have to worry about the plus c when you're using the integrating factor formula. Then ultimately, the integral of p of x dx is ln of x. So the I of x term will be e to the ln of x. Okay? Well, ln of x. Alright, now that we have this from algebra, you know that these ultimately cancel, so you're going to have x here. So your integrating factor is x. Well, since we have our integrating factor, now let's go ahead and multiply both sides with the integrating factor. So we will have x y prime plus y equals to 2x squared. Awesome. Now that we have our multiplied version of this differential equation with the integrating factor, we are able to see this. I hope you can see this. This is a product rule. This is the product of y times x dx. If you're struggling with creating this, I can suggest that you're gonna have integrating factor multiplied with y here all the time. So our integrating factor was x, so you're gonna have x multiplied with y and the derivative of that, and you should be able to confirm when this is happening if you're not sure of your calculation. So anytime you can confirm this by taking the derivative of this product, and it will generate you xy prime plus y equals to 2x squared. Now, let's try to integrate both sides and solve this differential equation. So if we integrate this integral of d dx, this will ultimately cancel. So from fundamental theorem of calculus, we are able to cancel that derivative, and we're going to call this yx equal to the integral of 2x squared dx. Now, this integral will be 2 over 3 x cubed plus c, and remember we didn't include the plus c in the beginning. Now this plus c will help us solve for the initial value. So we're gonna have this right hand side equal to yx, and then we want to solve for y when we're solving differential equations. So I'm gonna move over here and divide everything with x, so we can have the solution in terms of x. So y will be equal to 2 over 3 x squared, since I'm dividing x cubed with x, plus c over x. So this is the explicit solution of my differential equation. If we were given a initial value, we would be able to plug the initial value over here and solve for c, and this will generate us a particular solution.